I'm here to talk about how cloud makes it easier and harder to detect bad stuff. Now, I am talking a little bit more specifically about AWS, but just keep these concepts in mind as you use whatever cloud platform of your choice. It applies across Azure, Google, AWS, the next big cloud provider, so just keep that in mind. So standard forward-looking statement. I won't be talking about any like Splunk specific products today, but we just put that in our presentations anyway. So who am I? A little bit about myself. The only thing you need to take away from this slide is the fact that I am based out of here in San Francisco at the Splunk headquarters, but my focus is on security and Splunk for security specifically. So if anybody who's a Splunk customer, anybody? Lots of people, awesome. If you don't know anything about Splunk, feel free to reach out to me and get connected. But more specifically around Splunk and AWS today, and it's something that we've been exploring a lot over the past year or so, and I can also give you some cool background if anyone's played Boss of the SOC before with Splunk. Anybody? Yep, one of the scenarios is AWS, so that's how I got my exposure and introduction to AWS. So the key things that we're here to cover today are these three goals. Understanding what AWS services your on-premises technologies correspond to. Understand what data is security relevant. Where should you get that data or how to get that data? And then also how to use that data to detect the bad stuff, the malicious stuff. So we'll start by looking at comparing security operations on-prem to similar components and controls of the cloud environment. Again, this is AWS specific, but it might be it's very transferable to your other cloud platforms. We're moving to the cloud, but we don't know where to get that security data, or the cloud is so different, or we can't deploy our familiar tools into the cloud, or where do we start? How do we interpret this cloud data? These are common questions that we hear a lot. Do you have these questions on your mind too? Yes? No? Don't be shy. Safe space. Yeah? So good. Then you're in the right place. So looking at this sort of diagram, what we're trying to translate here is that your on-premises data comes from endpoints, right? Network, infrastructure, or your services and applications today, right? This is talking on-prem. So effective security monitoring is accomplished by collecting data from all of these different relative locations across these technology stacks, right? So ultimately, what you want is collecting data or information from OSI layers 1 through 7, being the physical layer all the way to your application layer, right? And so traditionally on premises, we've been accomplishing this by collecting network data, say from a spanner tap, an IDS, NetFlow, or even wire data. When we talk about infrastructure data, maybe we've been collecting it from Active Directory, AAA, network access control, endpoint data from endpoint agents, or syslog, OS query, or your host logs themselves, and even application data, web access logs, for example, or custom code that's generating log data of their own. But think about the cloud and how this pertains to the cloud. The same model actually applies to AWS. Some of the components that you use on-prem today are also reusable in the cloud in the same manner, such as using wire data or using syslog or even OS query. AWS also provides additional telemetry on top of that for all of their virtualized services that they provide. But of course, ultimately, the trick is knowing which of these pieces of the telemetry helps detect the threats against what you're ultimately trying to protect, right? So using the same model or a similar model as to the previous slide, the cloud also uses the same data pillars: endpoint, network, infrastructure, services, and applications. So let's look at some of the examples of places in AWS where you can access security relevant telemetry. You'll also note that at the bottom, right in the middle, the analytics engine says Splunk. Well, that's because my wardrobe today is powered by Splunk, so therefore it's on the slide. So jumping into that, let's start with endpoint. In many cases, the same on-prem endpoint agent can be used in the cloud as well, such as OS query. Is everyone familiar with OS query? Yeah, pretty powerful. It's really cool. Additionally, AWS provides native EC2 agents such as Inspector or CloudWatch, which might be akin to something like your ESXi logs, right? Then moving over to network. Today, on-prem, we might be collecting it from spans, taps, et cetera, but in the AWS world, their customer networking stack is collected a little bit differently. You're collecting network telemetry, such as VPC flow logs. That can be centrally collected from the infrastructure. Additionally, you might consider laying on some wire data solutions that provide additional network visibility from an endpoint capture perspective. Then, for infrastructure, here we're talking about underlying technologies such as your authentication or your authorization or your accounting services, network access controls and policies, vulnerability information perhaps, and even service availability, think Nagios or Zabbix. AWS also provides a significant amount of all of this infrastructure-related data through a service called CloudTrail. And CloudWatch logs, CloudWatch metrics, and then a policy configuration called AWS config, which helps you monitor things like password strength adherence or multi-factor authentication, rules that you set on your S3 buckets, for example, like if they were publicly available, let's say. Then when we come to application services, you might, in the realm of AWS, be leveraging relational databases. You might be leveraging storage, S3 buckets, the web application firewall, for example. They all happen to generate native security relevant telemetry. But then on top of that, you might have custom applications where you're using something like Lambda to bring in that data set. Think of custom applications for proprietary code or any software code. They present the same challenges you have today on-prem, right? Adequate security logging and monitoring is dependent on the custom application that's generating the log events themselves. So you need to ask your developers to leverage a logging standard that's going to generate that security relevant data when defined actions occur. Think like new network connections or how much data is being pushed through, privilege modifications, what user actions are taking place, and so on. Right? The events at a minimum should contain a timestamp with the time zone, perhaps, the action that's transpiring, and the response that indicates success or failure, and then maybe some sort of account or user identifier as well. And that's where you look at the services and applications. Of course, all together, this is where they're all pieced together across the board, across all the different data pillars. We have a number of security relevant sources from which we can collect log data from. Does that make sense, everybody, so far? Cool. So if you're just getting started with AWS, and you're thinking, I need to kind of lift and shift my web application into the AWS realm, what do you need to do, or how do you get started? Well, AWS provides reference documentation for common solutions such as web application hosting or content delivery networks, online gaming, and so on. These guides describe the common solutions to these particular architectures that you're looking for, and then more importantly, describe how the components fit together. So if you just go out to Amazon's website and look for Architecture Center, for example, you can pull up some of these reference guides, but you can see all the way in the back, you've got your relational databases. In front of that, your application servers. In front of that, it sounds much like on-prem architecture, right? And then so using this matrix, or using a matrix like this, plus the reference architecture from the slide before, like this, you could then essentially map it back to the corresponding on-premises solutions to help it make sense, to help you translate the technology and the terminologies. So when you've got your networking teams coming to you or your storage teams coming to you, they're like, how do I make sense of this? Now you can translate the services, the AWS services, to what they would be traditionally known as on-prem. Make sense? And of course, I'm not going to read all of that to you. The AWS shared responsibility model. Everyone familiar with this who uses AWS? I see a few nods. Anybody who uses AWS that doesn't know this shared responsibility model? Okay, just being shy. The point is, don't forget that security and compliance is a shared responsibility between you and AWS. Of course, AWS is responsible for the infrastructure level, the networking level, and all the services that are offered there that are facilitated through AWS Cloud Services. But you, as the customer, you have responsibility for all the services that you elect. Just like on-premise infrastructure, you have to harden your systems. We've heard that a couple times already today. You have to test for vulnerabilities and then apply strong network policies. That's just a few examples. And so how can you use that AWS data to help you detect malicious activity? So here are some ideas that we put together in a couple of slides. So you'll notice also if you are ingesting your AWS data into Splunk, for example, I saw a couple of hands, there is a third column that calls that out. So in case you were wondering, how do I do that, make sense of that? So here's one slide, and yeah, it's definitely hard to read on the slide itself. But the first one, for example, calls out billing. Like, why would you care about billing? Obviously, besides maintaining or predicting your expenditures, you might want to look at how your AWS resources are being consumed. You might want to see if anyone's running up any money by inadvertently or purposefully spinning up services that you didn't authorize. That's very important to look at billing insights. You might not think of it traditionally as an IT or security aspect, but it certainly can be. So that's just one example. And so the other ones call out a few other ones. Now, this is not exhaustive by any means, but just gives you some preliminary ideas to work with. And so here's a few more on another slide. Another often heard statement, how do we detect attacks in the cloud? So approaching this from a methodology perspective, securing cloud solutions is not unlike on-prem. Anybody familiar with crafting the InfoSec playbook? Oh, okay. Good reading. I recommend it. The playbook methodology detailed in this book helps you determine things like, what do we need to protect? What are the threats that those things that you're trying to protect may face? And what data would you need to detect those threats against those things, right? And so this 4-step repeatable process is how the authors approach securing any component of any environment. So also go back and look at your hybrid environments. Think about your on-prem tasks or things or assets that you're trying to protect, and also as you migrate them to the cloud, same methodology. So now looking at that architecture diagram, putting it together into this kind of threat-based monitoring plan, and layering on the methodology, the playbook methodology, to that same web application environment, we can now break down the architecture into its individual components and identify the various threats against each of those components. And then so in the last column, if you could read that, it says a detection logic. And so those are actually the beginning stages or the little baby steps that you're taking towards what will become the detection queries against the data that you are ultimately going to collect. Does that make sense? Nice little whiteboarding exercise with your teams. But let's dive down in one of these deeper so you can actually see what it says. So taking the web infrastructure as an example, why would you care about an instance created by an unusual user or a user that's never been seen before? And then you start asking, how would I get that data? Then you ask, how would I detect for those threats against that data? So think about if all of a sudden an instance was created from a user that you've never seen before, that's unknown to provision accounts, and this isn't a user who suddenly changed roles and become an admin or a super user, or you haven't applied a new orchestration tool in your environment, what would that suggest? It could potentially suggest that credentials have been created or compromised, and now your environment is controlled by the adversary. This could also result in a potential cost run-up, like I mentioned earlier, by looking at the billing data. So now you can correlate your activity, your account activity data, or your provisioning data through CloudTrail with something like billing to then do a more high-fidelity correlation. So let's take a deeper look into 2 specific examples on how this data could be used to detect malicious activity. So breaking down and looking at CloudTrail first. By AWS's own definition, CloudTrail is a service that enables governance, compliance, operational auditing, and risk auditing of your AWS account. All AWS security services integrate with CloudTrail. The CloudTrail events are accessible in your AWS Management Console for 90 days. And all user activity, role changes, or service attempts are logged via AWS CloudTrail. And the audit trails are then saved and even archived into S3 buckets. So on top of that, you can layer it on with CloudWatch activity for further evaluation and alerting. CloudTrail has become so crucial and valuable for all security operations that it's actually enabled by default, in case you didn't know that. So what does it look like? So when you're starting to work with CloudTrail logs, what might you expect? Well, first is understanding the logs come in this kind of format, which is very interesting and long. But if you were to bring that set of data or those set of logs back into your own environment, this is what you could expect of kind of that log format. And just to kind of break it down really simply for you, just know also that the timestamp doesn't refer to just that particular activity. It can refer to any records written prior to that point, before that time stamp of that file. The unique string, the 16-character unique string, is actually kind of nothing. It's really just to make sure it doesn't get overwritten and that it acts as a unique string. And then currently the file formats, as far as I know, is only in compressed gzip JSON format. And then if you wanted to break down the contents inside, that's the link to break down the CloudTrail events themselves and the contents of the log file. But we're going to actually look at one here shortly. So this is what a CloudTrail log might look like. This is actually what it looks like in Splunk, so it's really pretty. But behind the scenes, it's really just a JSON blob of all these different things. But why is this important? So again, it's understanding the data. What does the data contain? What are the relevant fields? What are these key fields that I should look at? So this particular CloudTrail event contains information also about what was requested from a resource standpoint. Which account was it requested against? Additional parameters about that particular request, and so on. So now you have the who, what, when, where, and why. Remember back to your elementary school days, for example, you're doing hypotheses and you're answering those questions. That's the same kind of thing as an investigator. And then furthermore, there's a particular field there, let's go back real quick, of an event name. In this case, this blob shows get caller identity. That was the particular action that transpired. But there are other examples of possible activity that could be attempted. And this is just a short list of stuff. But basically what we're saying is that you can take these requested actions and correlate that to many other AWS services, particularly something like an identity, so that you can then assess who's analyzing it, when did they analyze it, and so on. It's much like understanding in an on-prem environment who's launching what processes and on what endpoint. That's essentially what you're doing. Does that make sense? Yeah? And so the names are pretty descriptive, in my opinion. I've worked with many of them, and I feel like they're also very prescriptive. They tell you kind of what's happening, your getters, your setters, your creates, things like that. And then it also gives you an idea, is something being written or something being read? So that's really important, so you know which way it's going. And then, of course, what is the actual API call that's being made? Does anything stick out here for anybody? Does anything just jump out and go, whoa? Yeah, run instance is a lot higher. So why would that be? Any takers? Sure, excellent, right? So we don't know. We don't know, but we can start to speculate. We can, as an analyst, we might start to say, hey, is someone doing crypto mining? Is there a possibility that we're involved in a DOS attack, or are you just simply trying to harm me and make me pay a lot more to AWS and then cause me to go bankrupt or something, right? There's a lot of inferences that can be made, but certainly that's the tip of the investigation. We start to wonder, why does that stand out? And why is someone doing that against our environment? You could even historically compare it to baseline activity of run instances to see if on average 10, 20 a day, but then all of a sudden you get 576, that is definitely suspicious and a red flag. That's an opportunity to set off an alarm. Here are some other ideas. So again, when you crack open that CloudTrail log, it's like a DIY method or doing it yourself, where these are additional bullets of examples of CloudTrail insights that you might want to get just by cracking the log open yourself and doing some simple correlations. These insights are actually accessible just by looking at CloudTrail logs. So you might consider authorized versus unauthorized identity activity, and then you can see errors that might arise from that. Anything that's related to your networking environment, VPC errors, security group errors, anything affecting your network policy, anybody accessing your environment using key value pairs, SSH keys, things like that, network ACL errors that might arise, or even unauthorized versus authorized activity of any user or any of those API calls. Those are all things that can be possible with just CloudTrail data. Pretty powerful, right? That's the first thing you probably want to do is crack open some CloudTrail logs and get back. So on the flip side, so that was previously the DIY method. Now, there's also, AWS offers a lot of services that help you do security monitoring and security detection. One of them that I particularly am fond of is the AWS Trusted Adviser. Does anybody use AWS Trusted Adviser? Oh, great, awesome. So you're familiar with what its capabilities are. Hopefully you'll still learn a couple of things. So it was launched in about 2013, if I recall correctly. This is kind of how it works for those who are not familiar with Trusted Advisor. They offer various tiers of service as well. So there is a free tier as well as a high-end premium tier. But at its core, AWS Trusted Advisor helps you observe AWS best practices. Right? You're always like, what are the best practices for any environment? AWS is no different. So it helps you scan your AWS infrastructure in 5 specific categories: cost, specifically cost optimization, performance, security, fault tolerance, and your service limits. And then it makes recommendations for you to help you save money, of course, improve your system performance and reliability, or closing security gaps. And then if you were to integrate the AWS Trusted Advisor to some sort of on-prem solution or analytics engine, you could bring those in via CloudWatch events or CloudWatch services. So here's a little bit more about the Trusted Advisor and what the best practices actually entail. So there are 7 core checks. When they first started, I think it was just 4. So now it's up to 7 core checks. And they include everything like security groups and bucket checks and database access risks, exposure of your snapshots, the presence of CloudTrail logging and ELB security groups, even exposed access keys. But very, very important note to take away about these best practice checks. It is just practice, and they are the key risks. Key as in the most prominent or the most common risk to help you assess your environment, meaning it doesn't address all the possible security issues or even all the possible threats against your environment, your data sources, your applications, et cetera. So please keep that in mind, right? And I mentioned they already have, it's a multi-tier service that they offer, but with the example that I previously showed with CloudTrail, definitely consider layering. Just like we say in security, layer your defenses, right? Layer your monitoring here in this case as well. Layer it with the DIY method, cracking open the logs yourself, looking at additional security detections, as well as leveraging one of these turnkey solutions that AWS offers out of the box. Right? And then service limits help you understand how close are you converging towards your service limits, just like we were talking about billing, or we're talking about resource utilization. If all of a sudden you're getting tons of spikes in resource utilization across your environment, then you definitely have something to worry about, right? And AWS also provides a standard list of the default limitations and anything that you could alert on and the thresholds that you might consider alerting on. Does this all make sense? Yeah? Good? Okay. So we've only really just seen the tip of the iceberg. So I only showed CloudTrail, only talked about AWS Trusted Advisor. There are hundreds more of AWS services and data sets that you could be combing through, that you could be looking at. But there are also so many wonderful online resources provided by SANS, but also by AWS themselves, like the SANS Reading Room, blog posts, webinars, AWS documentation, and so much more. So make sure that you leave here today, but you also go out there and search and learn, continuously learn all the time. And so the key takeaways, again, it's so important to become familiar with the AWS data and what you can glean out of that data set. You also want to understand where to find that security data. So a lot of it is in the documentation, a lot of it's in the management console, a lot of it is simply just about toggling a enable versus disable button, but it's really important where to look for that. And then more importantly, how to use that data to detect malicious activity. And if you were to integrate that downstream with any other solutions or analytic engines you have on-prem or even additionally in the cloud as well, know how that integration should happen or can happen, right? And we're here to also help you provide some guidance there. At Splunk, we also have a series of blog posts in what we call Hunting with Splunk. It's a series that covers a lot of single concepts and helps you break it down. We also cover AWS CloudTrail and VPC flow data in a little bit more detail in that blog post. So please feel free to read that at your leisure. Ask me questions afterwards or whatnot. The idea behind our blog posts are actually to help you try to develop a solid base level understanding and knowledge so that you can use it in your own environment. Translate that to help you hunt for all that badness and all that evil in your environment. And that's it. Any questions?